So chapter 3 is going to be about quadratic functions. And we talked about earlier in the course that each time we talk about one of these new function classes, we're going to be concerned with these three skills primarily. So we were going to be concerned with being able to draw the graph for the function, being able to simplify algebraic expressions involving that function, and solve equations involving that function. So these are the three primary skills. Now there might be other stuff included in there too that kind of support these skills. But these are going to be kind of core skills every time we start a new chapter. These are going to be kind of the big assessment items kind of at the end. So some of this stuff is going to be coming mostly out of the book. So things that we'll do in the notes that I'm going to talk about. Some of these things are going to be stuff from the book, but I do need to support some of those things that are even in book with some out-of-book things as well. So there's some stuff the textbook assumes you have mastery of mastery of that I don't for this course, that we'll spend some more time with. So even on the stuff that the book does, I think, a fine job with, I have to do a little bit of extra support because there's stuff that I think we need additional practice on in my experience. Okay, so that being said, we're going to start today talking about graphing. And we'll start by defining what we mean by a quadratic function. So a quadratic function can be written in any of these forms. The first form is called vertex form. That's y equals a times the quantity, x minus h, quantity squared plus k. Could be written in intercept form. That's y equals a times x minus p times x minus q. And the third way is in something called standard form. That's y equals ax squared plus bx plus c. Juan? P and q in number 2. Yes, x minus p and x minus q. So the graph of a quadratic function, we call that a parabola. So a quadratic function, parabola, will look like one of two ways. It'll look like a U, or it'll look like an upside down U. For the record, parabolas can open up sideways as well, but those wouldn't be functions because they'd fail a vertical line test. So for this course, when we talk about quadratic functions, we're only talking about parabolas that either open up or open down, not ones that open left or right. One of the key points on a parabola, and a point that's going to be of special interest to us, is the vertex. So just like an absolute value function, the vertex is kind of that highest or lowest point on our graph. Note that unlike the absolute value function, the parabola is curved as opposed to straight lines. I would be picky about that on your graph if you drew a parabola with straight sides as opposed to curved sides. And our first thing that we want to talk about is being able to find that vertex. So if our equation is in vertex form, our vertex is just h comma k. That's the easiest of the situations. So to find our vertex, if our function is in vertex form, all we have to do is identify the h and k and we're done. Oops. I guess I should probably write these as f of x's and not y equals. And there's not really, I mean, you can use them interchangeably, but the notation that I want to use here is easier to deal with if I write them as f of x's. So that's what I'm going to do. So the intercept form, the vertex here is the point, the x-coordinate is p plus q over 2. And then to find the y-coordinate, what I'm going to do is I'm going to take my answer for the x and plug it back into my function. So when I write f and then a number in parentheses after it, what that means is I'm going to take that number and plug it in for the x's in my function. So basically what we're saying here is I figure out what the x is and take that answer and plug it back in to figure out the y-coordinate. We'll do an example of this in a moment, so you guys, if you're not familiar with this notation, it's not difficult, but if it's unfamiliar, it's unfamiliar, you know. And then the last situation is if it's in standard form. And in standard form, the vertex, the x-coordinate is negative b over 2a. And to find the y-coordinate, we're going to do the same thing as we did before. We're going to take that value for x and plug it back into our function to find the y-coordinate. Okay, so let's do some examples of finding the vertex. So let's say we have f of x equals negative 2 times x plus 1 times x minus 7. I'm going to start by identifying which of the three forms my function is in. Is this in vertex form, intercept form, or standard form? This is in intercept form. Very good. And I know for intercept form, to find the vertex, I need to do p plus q over 2. And then f of p plus q over 2. So let's first start by identifying my values for p and q. What is my value for p? Did somebody say, what was it? It's negative 1. Remember that because I have a subtraction symbol in my general form, the p is going to be the opposite sign of what it appears in the function, just like the h's were. That being said, then, what's my value for q? 7. Okay. It's not negative 7. Just like with the h's, it's going to be the opposite sign of what it appears in the function. So to calculate my x-coordinate, then, I'm going to do negative 1 plus 7 divided by 2. That gives me 3. To find the y-coordinate, I'm going to do f of 3, which means I'm going to do negative 2 times 3 plus 1 times 3 minus 7. The order of operation says I should do stuff inside the parentheses first. 3 plus 1 is 4, and then 3 minus 7 is negative 4. And if I multiply those together, I get 32. So my vertex is the point 3, 32. Negative 1 plus 7 is 6, and 6 divided by 2 is 3. I plugged it in to the x's in my f of x up here. Okay? Yeah. So what f of 3 means is I'm going to be looking at my equation for f, which is this. And everywhere there's an x, I'm going to replace that with a 3. Okay? So that's what I did here, and then I just simplified.
What is that?
I added 3 plus 1 and subtracted 3 minus 7. Parenthesis 4. Parenthesis negative 4. Okay. Sorry about that. Next, let's say we have f of x equals negative x plus 4 squared minus 5. Oops. Which form is this in? This is vertex form. And I know in vertex form, the vertex is h comma k. So what's my h and k in this situation? K is negative 5, and h is negative 4. So, and I'm done. Yeah, Juwan? Yep. Plus a negative 5 is the same thing as minus 5. Right, so k is negative 5. Hold on, guys. That is standard form. We're going to run out of time and just like if you guys can stay till we finish this example. No, I'm not kidding you. And yeah, I did hear that. So to find the x-coordinate, I need to identify my a and my b. So my a here is 2, and my b is negative 3. So I have negative of negative 3 over 2 times 2, or 3/4. To find the y-coordinate then, I'm going to do f of 3/4. That means I'm going to have 2 times 3/4 squared minus 3 times 3/4 plus 5. To simplify this, the first thing I need to do is deal with the exponent. A fraction squared. To do that, I square just the top of the fraction and the bottom of the fraction. 3 squared is 9. 4 squared is 16. And then to multiply fractions, I multiply the tops and bottoms. So I'm going to think about these as fractions. The first fraction I can reduce as I multiply. So that's going to give me 9 over 8 minus 9 over 4 plus 5. To subtract these fractions, I need to have a common denominator. So I'll multiply the second fraction by 2 over 2 to get a common denominator of 8. And the 5 I'll multiply by 8 over 8 to get the common denominator of 8. And if I combine these, I get 31 over 8. So my vertex is 3/4, 31 over 8. I am going to post an assignment for this topic to PowerSchool. Would not be due till after the test.